Hello everyone. I have another piece of precision test equipment by Agilent for repair here. This is a power supply, or as they call it, dynamic measurement DC source, model 66312A. Something is wrong with it. Apparently there is some mechanical damage to these binding posts. It seems like the unit fell on these posts or something like that. They are smashed a little bit, especially the bottom one. And also the keypad is pushed in. And other than that, it is in a pretty good shape, on the outside at least. And it powers up, but there is nothing on the display. Let's try powering this up. So I can hear the transformer hum and the fan is running, but as I said, nothing on the display. So let's see what can we do about this. Here is the back of the unit. Everything looks fine here, no mechanical damage. And this thing has both GPIB and serial interfaces. So I'm thinking about trying to talk to this thing first, but I will have to experiment because I don't know which port is configured and we cannot see the configuration. But let's try the default first, which is GPIB, and the default address is 5. And if that doesn't work, I'll try different addresses. There are not too many of them. And if that doesn't work, I'll try the serial interface. There are also several options there with speed and parity and such, but it shouldn't be too hard to figure out if it works at all. Aha, I'm lucky here. The default address worked, and this command is to get the ID of the device, and here it is. No problem at all. So let's set some voltage. Let's say 10 volts, and let's turn the output on. And I see 10 volts, no problem at all. And here it is, 10 volts and quite precise. I am happy about this. So it seems that the only problem is with the display. And I have a few videos already about repairing similar displays. So let's see if we can fix this one. The cover is off and everything looks fine so far. The power supply is on the bottom board and all digital control is on this smaller board on the top. And this ribbon cable goes to the front panel. So let's take the front panel off and have a look. So I took the front panel off and this board fell right out. And here is our problem. These white spots mean that the VFD display lost vacuum and it needs to be replaced. And for some reason there was no nut on this encoder holding it in place on the front panel here. And it has to be there because this board is held here by these plastic hooks and the nut prevents it from sliding. The way to remove the board usually is to unclip this window, remove the window first, then undo the nut, and then slide this board slightly this way and lift it up. And the nut is missing. I bought a replacement display on eBay. They are not cheap at all. The cheapest I could find is about $70 delivered from China. And this is almost beyond economical repair, because I've seen working power supplies for about $200. but I've got mine quite cheap because it is broken, so it still makes sense, and I decided to go for it. It took quite a while to arrive, about 3 weeks, and unfortunately I see a small difference. The picture on eBay showed exactly the same configuration as this original one, but this display I received has extra symbol 4 here and 2 extra small bars under AC and DC symbols here. Perhaps not a big deal, and the seller insists that they are completely compatible. I hope it is so. I guess we'll find out. Here I have my PACE desoldering station with this SX90 handpiece, so desoldering should not be a big deal. Here they are, side by side. The original is branded Itron, Japan. And I think I've seen a crack somewhere. Oh yeah, there it is. Crack in the glass. And the replacement is branded as SOT here. The replacement display is soldered. Let's give it a go. It's working, nice and bright, no problem at all. Now let's look at the binding posts. They are damaged, and I believe this was the reason the display was cracked. Perhaps the power supply was dropped and fell right on the binding posts. And I think they still work fine as banana jacks. And this one even works for spade terminals and bare wires, as it should. But this one not so much. It gets stuck at some point. And anyway, they look quite ugly, so I decided to try this set. So I bought it on eBay from China again, and they are described as Agilent banana terminals, and I think they are intended for a different model, for something like E3631 or similar. So they have slightly different color plastic, and for some reason Agilent put both red terminals on these models. I'm not sure why. Perhaps they wanted to emphasize that they are floating, but I still would prefer having a black one for negative. And this red ring is gone, obviously. So let's see if these fit. And these should be easy to remove, and just undo these two nuts. Alright, I removed the old binding posts, and it seems like the new ones are very, very tight, but should fit fine. And this plastic thread is not used at all, so they are held by this metal thread to this little board. So they should work just fine. Here is the result. And slightly different color. It does not look too bad in my view. I don't mind this at all. Much better than the damaged ones anyway. So I believe this should work just fine. The front panel is back together. And I added here a missing nut and a washer. I replaced a few encoders in similar models before, so I had a few extra nuts and washers sitting around. So the front panel is ready to go. The supply is back together, and I prepared my electronic load to give it a test. I set the voltage to 20 volts, and I set the current limit to the maximum it can be set to, which is slightly above 2 amps the supply is rated for, and this is to avoid going into the current limited mode so that voltage wouldn't start dropping when we give it 2 amps load. So let's enable the load, and there you go, no problem at all. It works just fine. I like this line of power supplies a lot. First of all, I like the resolution on the screen of both voltage and current. Sometimes it is very handy to see down to millivolts and down to hundreds of microamps. For example, if I'm troubleshooting something or charging a lithium-ion battery, let's say, it's easy to see that voltage is going up slowly and current is going down slowly, let's say, if a battery is charging. And that might be not easy to see on a power supply which only has 2 decimal places after the dot. And also these are 2-quadrant power supplies, meaning that they can both source and sink current. And I have a video showing how to use such a power supply to test a lithium-ion battery, to charge and discharge using just a power supply, and I showed that in my video, and I wrote a program in Python controlling a power supply using GPIB interface to do all that. So I'll put a link in the description, check it out if you are interested. And also there is a reason they are called a dynamic measurement DC source, not just a power supply. They are designed, I believe, to handle quick transitions. Let's say if you're developing or troubleshooting some device with a spiky load, for example a cell phone which can turn the transmitter off and on, that changes current consumption significantly. These supplies are designed to handle transitions really quickly, and also they have some feature to measure these things quickly through GPIB. I have not used this feature myself, but it's nice to have such a thing just in case. So there you go, we have this nice precision Agilent lab supply repaired and working just fine. Thank you very much for watching. Bye!